Hi, my name is John Painter, and I'm the CTO for Cloud. I've spent the last 15 years helping security-conscious and highly regulated organizations move applications into the public cloud environments, specifically the 3 hyperscalers. As an organization, we've focused on some of the technology, process, tools, strategy, and operating models that would help support what we call a cloud at scale migration program. What's an at-scale migration program? Typically, that would be applications in the hundreds to thousands of applications in a large enterprise. Healthcare, telecommunication, and financial services. So what I'd like to cover today is 2 primary things: some of the technology considerations and some of the operating model considerations when we talk about these cloud at-scale migration programs. Diving into technology. When we look at the technology, there are 3 specific layers that we have to identify and address with an at-scale program. The first layer is what we call the foundational layer. The foundational layer is all multi-tenant resources that go on to support the applications. What do I mean by multi-tenant? So for example, if I want to deploy an EC2 or an EKS cluster, I need things like accounts, subscriptions in the case of Azure, networks, core services, core identity, connectivity back to my existing enterprise estate. These are all resources that are multi-tenant in nature in the fact that they support multiple applications. The second consideration around foundations is it's very important to understand what we call the at-scale topology. So for example, when we're at scale, it's probably not possible to load all of our applications into a single account or a single network. We will likely want to build multiple accounts for each application in what we call an account per application model. And that also requires scaled out networking that supports, for again, a network for each application. So these are things that we address and look at in the foundational layer. The second layer we have to look at is what we call the control layer. The control layer is essential for a highly regulated or security conscious organizations. Again, specifically people like financial services, telecommunications, and healthcare. The control layer are the resources that ascertain and monitor and control the underlying workload resources. There are 3 steps to this process that are important. The first step is what we call threat modeling. We take a service, again, let's use EC2 from AWS, and we understand all the threats that this service presents. What we call a threat, for example, is understanding how encryption or identity or network affects that service and how you would like that to behave in your ecosystem. That's what we call threat modeling. Once we have those threats, we go into the second part of the process, is what we call control engineering. Control engineering is where we build compensating controls that help us either monitor, maintain, or mitigate those threats. Control engineering is actually writing code and writing specific controls that get loaded into tools in these public cloud providers. So the third layer is what we call control distribution. Control distribution is picking up the relevant controls, pushing them and maintaining them into those ecosystems. And once again, that can be an at-scale model. If, for example, we have 100 applications or 1,000 applications, we might have 100 or 1,000 endpoints that we have to monitor and push controls on. Again, this is a very important layer for these highly regulated and security-conscious organizations. The last layer that we talk about is what we call the workload layer. The workload layer is where all workload or application-level resources sit. In the workload layer, we have services in Amazon such as EC2, S3, EKS. In Azure, you have things like AKS, SQLMI, etc., etc. These are the actual workload resources that support the underlying applications. The workload layer is important because there is a lot of different modes in how to provision and maintain the workload resources. For example, you have at-scale migration programs that might be lifting and shifting resources across, but at the very far end of the scale, you've got full DevOps models, which might be, for example, provisioning the workload resources on a daily or even inter-daily basis, and doing things like blue-green, stack rolling, traffic migration, etc., etc. You also have resources such as containers and container clusters that live in the workload layer. So these are 3 layers. One of the things that's very important to understand is these layers have a different frequency as well. While the foundational layer seems like a fairly static resource, it does undergo change. The providers can quite frequently change their opinion of how they want foundational resources to deploy. For example, not that long ago, it was fairly common to load a lot of applications into a single account. Nowadays, the best practice and the technology is there to offer an account for every single application. That has changed the foundational layer, and that might happen quarterly or even annually. The control layer is relatively high frequency, requires probably monthly updates as the providers change the services and add features. The workload layer, like we talked about, can be incredibly high frequency and undergoes a lot of change. Okay, the second half is the operating model that supports this. The operating model has two core pieces. The operating model has what we call the platform engineering team. The platform engineering team is the team that looks after the foundational and the control resources. The platform team also looks after what we call the at-scale principles. So the underlying topology that says, for example, are we going to use a single account with a single network, or are we going to do an account per application and a network per application? They are responsible for building, scaling, and maintaining the foundational and the control resources. The second half of the team is what we call the application enablement function. The application enablement function looks after all of the workload resources. So for example, if I have an application that wants to go to cloud, they have to engage, assess, migrate, and operate that workload for the migration. So that's the application enablement team. It's commonly assembled into pods, and each of these pods will be given an application to run through that process and to complete that work. So what we've covered today is both the technology and the operating model for what we call a cloud at scale program. Once again, cloud at scale is very important when you look at your ecosystem going from perhaps 10 into 100 into even 1,000 applications. So I hope this has been of value. I hope you have a great day. Thank you very much.